Okay, so we've been solving multi-step inequalities. Just to recap a couple of things before we start. Remember, your first step is distribute on either side, then combine like terms on either side, move the variable over by adding or subtracting, and then solve the remaining two-step, which technically is called like 7th grade level. But the kicker is when you get to that very last step, which is ultimately going to be division, figure out what you're multiplying by, because if you divide by negative, we have to flip the inequality, which ultimately affects the shading of our number line and then the interval notation. Now, we're going to talk about some special cases today, which are similar but not the same as equations. So just make sure to follow along till the very end. But let's start with some review. Again, I'm going to kind of pick and choose just for notes purposes, but let's look at number 1. So the first one is distribute where there are parentheses. Now here we're going to distribute -7, so I'm going to bring down that 3x. -7 times x is -7x. -7 times 3 is -21. On that left side, when I do combine like terms, remember I call it squares and circles. My variables are 3 and -7. When I add them together, 3 plus -7 is -4x. Since the only constant is -21, I bring it down. On the right side, there's no distributing, there's no combining like terms, so I just bring down the -13. Then I solve the remaining two-step, which is technically 7th grade, where you see addition and subtraction first. Where I see subtracting 21, we're going to do the opposite and add 21. -13 plus 21 is +8. And then my 21's canceled and I have -4x here. Now again, our last step is ultimately division. 8 divided by -4 is -2, but let's talk about it. Since I divided by a negative, the variable term is a negative, I'm going to flip the inequality like that. So it's no longer less than, it's greater than. So then open or close circle. Apologize for the video. So then because of the inequality, and one thing that I stress is that with the variable being on the right or left side of the inequality itself helps in shading. So with the variable on the left side, the inequality points to the direction of the shade. So it's an open circle on -2, and greater than is shaded to the right. Now, if we want to take it a step further into interval notation, remember, think about how far left this graph goes. Since it's an open circle on -2, it's a parentheses. And since it goes forever and on to the right side, that's positive infinite. And infinite, because it has no barrier, is parentheses as well. And again, I'm going to jump around just so for time purposes, but let's jump to number 4. Now, when there's parentheses, it's implied that there is some kind of distribution. Here, though, you're not distributing by 5, you're distributing by -1. So you bring down the 5x. -1 times x is -1x. -1 times -2 is +2. If we combine like terms on that side, 5x and -1x make 4x. I bring down the +2 since it has no other constant to combine with. On the right side, I'm going to distribute -4x. -4 times x is -4x. -4 times -8 is +32. With my combined like terms, 2x and -4x combine to make -2x. And then I bring down that +32. Now, when it comes to this grade, I call this the 8th grade level more or less, because I want to move the variable that's on the right to the left so that my variable ends up on the left. So the opposite of -2x is to add 2x here. And 4x plus 2x is 6x plus 2 is 32. Now, when I want to move the constant next, or solve the two-step equation, I see addition, I'm going to subtract 2. And 6x and 32 minus 2 is 30. Now here, because I'm going to divide by 6, that does not flip the inequality. So x remains greater than or equal to 5. Since it's a greater than or equal to, it's going to be a closed circle on 5. And again, because the variable's on the left, it helps me determine which way to shade. So the values greater than 5 are to the right. And so if I do interval notation, this time it's a bracket on 5 since it's a closed circle, and forever to the right implies that the infinite sign is on the right side of the interval notation, and it's parentheses. So let's talk about some special cases here. So this is where there's a connection between equations and inequalities, but they are a little bit different, so we have to watch out. So let's break it down first. solve as we normally do. So 4 times x is 4x. 4 times negative 3 is negative 12. There is no combining like terms, so I can stop there. 2 times 2x is 4x, and 2 times negative 5 is negative 10. Now here is where it's different than a traditional inequality, because when I move the 4x over by subtracting 4x, if you notice on both sides, the variables will essentially cancel. Now, this is where it's different than equations. When we solved equations, we looked at what the terms were. Now, when you take a first glance at it, you look at, oh, negative 12 is not equal to negative 10. Well, that doesn't matter here. So this is not a no solution example, and here's the reason why. You have to look at what the inequality is between them. It's still less than. Well, is this statement true? Is negative 12 less than negative 10 on a number line? And it is. So because this statement is true, this is not a no solution question. It is our all real solutions or infinite solutions. Now, what this looks like on a number line, since it's all reals, it would mean there is no particular point to be like circled or, solid or whatever, solid or open. It just means that the whole entire number line is going to be shaded from left to right. Okay. Now what this means is I could put any possible x value, like 2 and 2, or negative 4 and 4, or negative 4 and negative 4. Whatever value I put there, this statement will always be true where the left side is less than the right side. And so that's why any term would work. Well, let's look at the opposite side of that. So no distributing, no combining like terms. So I'm going to just bring that side down. Here I have some combining like terms. So 7m and negative 1m makes 6m. And then I bring down that plus 7. So here the variables also cancel. And again, because when I first look at it, it looks like, oh, negative 5 does not equal 7. But we have to check to determine if the inequality is true. So is negative 5 greater than 7? And this one is false. It's not a true statement. So this is what it would look like to be no solution. Okay. Now what that looks like on a number line is a blank number line. Like there would not be any shading. There would be no open or closed circle, because no possible term or number could I put in for the m variable where the left side would always be greater than the right side. So it wouldn't be possible there. But either way, so just to recap, it is like equations where the variables will cancel. So that's your first clue that it's either going to be infinite or no solution, or all reals or no solution. But what you have to pay attention to is the inequality and determine, is the inequality correct? Is negative 12 less than negative 10? Is negative 5 greater than 7? And if it is false, it's no solution. If it is true, then it's all reals. So just be on the lookout for that.